Hey everyone, welcome to our lesson on Law of Sines. Before we start talking about Law of Sines, we need to recall that sides of triangles and the angles opposite of those sides are going to be the related ones. So let me show you what that looks like. A side of my triangle here labeled B is going to have a special relationship with that angle opposite of that side. And typically you'll see the lowercase letters labeled on the sides of triangles and the uppercase letters as the angles. But no matter what you see there, just work with them in this way. Sides and angles across from them have a special relationship. That's what you want to keep in mind as you set up your law of sines. Law of sines is this here. It is that all of the sides and angles have a special relationship, and those relationships are equal to the other pairs. So in this triangle here, I have it labeled the same as the last triangle. Side A is to sine of angle A, who's across from A, just as B is to sine B, as C is to sine C. All of these ratios or relationships are equal. Okay, why do you need to know that? When do you need to use it? You'll want to use law of sines in the first place. Law of sines can be used in any triangle. So sometimes we're not given a right triangle or special right triangle, so we need to have a different tool to be able to find our missing pieces on our triangles. Specifically, you'll want to use this setup when you know two sides and an angle. And if you'll look right here, that's the case. I know two sides, one angle is labeled, and you want to find the measure of an angle opposite from a known side. So if you wanted to start here, find that angle opposite of this side here. Or you can use it when you know two angles and one side, as in this situation here, and you want to get the side opposite of a known angle, like this situation. Okay? So just take a minute and look over these diagrams. So when you know two sides and an angle, or two angles and a side. In either case, you must have a pair. You must have a side angle pair that goes together. So let's take this example, and let's hang in there because it's going to take us a minute to find these missing pieces, but I'm going to walk you through the whole process. Let's look at what we've got labeled here. We've got a side 16, side 49, some units, and one of the angles, 115 degrees. We do not have angle X. We'll be finding that. We do not have side A, and we're also missing this angle down here. If you notice, they didn't label it. Let's go ahead and call it something. We could call it maybe uppercase A, since that's the one that matches to lowercase a across from him. Find the missing parts. Okay, so let's work on setting up law of sines. So remember, it was A to sine A equals B to sine B and C to sine C. So if we take, and it doesn't matter what letters you have, but since the first thing was A, I'll just use this A pair here since we have that. So A, lowercase a, is to sine of angle A because those go together in this triangle. And then I'll go with the 16 sine X pair here. It doesn't matter that it's not a B, it just has to be a matching pair. That side 16 is across from that angle X, so they go together. And notice I'm putting my sides on top. Since I started doing it that way, I want to finish doing it that way. I want all the sides on top, all the angles on the bottom. You could reverse that as long as you're consistent, as long as you have all of the same type of thing on top and all of the same type of thing on the bottom. Alright, my last pair here is 49, and that goes with sine 115. Now notice this is the pair that we have both items for. We have a pair. So this is why we can start using this law of sines. You want to look at that, that's a special pair, and use that relationship with any of your other two relationships and start solving for your missing piece. So let me show you how that works. I'm going to focus right here. Okay? I have three things that I know in this ratio setup and one thing that I don't know. You can't solve for something where you have too many things that you don't know. So that's why I'm starting here where I don't know X. That's the only thing I don't know, so I'm going to find that first. So to do this, you see we have two fractions, set equal, and in that case we can cross multiply and continue to use our solving steps to solve. So taking those two things and cross multiplying, it would look like this. The diagonals are equal. So 16 times sine of 115 degrees, and that's degrees, okay, equals 49 sine x. Fill that in, okay? All right, so the products of the diagonals are equal. So what can I calculate now? I can take 16 times sine 115, and let's go ahead and do that in your calculator. 16 times sine 115. Make sure you're in mode degrees in your calculator. And these will be long decimal numbers, but you can keep as many numbers in as you go and try not to round too much. So I've got 14.5 roughly equals 49 sine x. And I'm trying to solve for x, so I'm eventually wanting to get x isolated on one side of the equal sign. So let's go ahead and divide out my 49, since I can get rid of it over here. And I have, going to round this a little bit, 0.2959 equals sine x. At this point, I can't just get rid of the word sine by dividing it out. To get rid of one of these trig functions, I need to use its inverse. So I'm going to take the sine inverse of both sides. So in your calculator, it looks like this. It's sitting above sine. So sine inverse of sine of x. Over here on the other side, I've got to do the same thing. Sine inverse of this number. And what that'll do is it's kind of the opposite of the operation sine, so that'll get rid of sine and just leave me with x by itself. Okay, so in your calculator, make sure it looks like this. You're going to want to pull up the sine inverse function and then type in your decimal number here. So type that in. And we have sine inverse. And I'm trying to leave as many numbers in here as I can and not round until the very end so it can be the most accurate. Alright, so round 17.21. And what were we finding? It's been such a long time, I can't remember. Let's go back and see. X, he's an angle. So 17.21 degrees, roughly. Alright, we found one piece. We found the piece here. And we still need to find a couple other things. We need to find another missing angle A, and we need to find our missing side A. So we're going to continue this on the next slide. Okay, now we have, let's fill that in, 17.21. We already found that. We did good. When you have two angles and you're just missing the third angle, that's a fairly easy thing because I know that the sum of interior angles in a triangle should add up to 180 degrees. So let's go ahead and find that one. So I have 115 plus 17.21 approximately plus angle A equals 180 degrees. So if you'll take the sum here and then subtract it from 180, that will get you angle A. So he is approximately 47.79 degrees. And as you're finding these, it's never a bad idea to go ahead and go label it in your triangle so you can see exactly what you have. Alright, now back to law of sines. So I had at the end of my setup last time, this 49 is to sine 115, this relationship here. And I want to go back and use that again because they gave me those two values. You always want to go back to the match that was given. Because if you go back and use two other pieces and one of them is something you have just found, if that piece is wrong, your next piece is going to be wrong too. So go back to the one, that's a good tip, to always use the one they gave you if you can. So I'm going to now use that relationship with A over sine of A. And since I know sine of A, I'm going to fill that in. 47.79. Okay. We're going to cross multiply again. And we're going to have the product of the diagonals, set equal. Okay, we're almost finished here. Equals A times sine 115. And notice again, I have 3 things that I know. I have 1 thing that I don't know. So I can solve for that 1 item. Alright, so let's look and see what we have. We could go ahead and calculate 49 times sine 47.79, that product. So type that in. You can work along with me. Now I'm trying to get A isolated. That's what I'm looking for, this guy right here. So I will now divide out sine 115 from both sides. So to sort of detach that there. It is attached to A with multiplication, so I'm doing the opposite of division. And that will leave me with A isolated, so that's a good thing. We just need to calculate this left-hand side here. You can go ahead and type in and get a value for sine 115 before you divide if you wish, or do it all at once. Just be careful and use lots of parentheses in your calculator. So I'm getting A, the side A, to be roughly 40.05 units. We'll go back in and label it just for fun. Okay, let's look around. Have we found all the missing pieces to our triangle? Looks like we have no more missing sides or angles. So we are good to go. That is our lesson on law of sines.